Hello, everybody, and welcome to episode 2 of the Reverse Engineering Plus Plus podcast. Your hosts are me, Aaron, and
Me, Dell.
oh, yeah, hit that one. It only took us 3 episodes, but we got it. Mission accomplished.
1 out of 3 is not terrible.
So, in this episode, we were going to start off in what will soon to be a series of episodes where we kind of attack the common approach, or a approach at least, that we take when it comes down to reverse engineering hardware. In this first one, which is probably going to be a part one of N series, we're going to be talking about different types of memory, and we're going to be talking about some of the kit that you use to be able to pull that memory down. Specifically, we're going to be talking about the TL8662 Universal Programmer and some gotchas and some additional stuff and considerations with those. And then they're just also kind of riffing about different memories. But before we get into it, though, we had kind of a recommendation, or they had mentioned with the show, like kind of who is your target audience, or where do you find yourself in your podcast, in the midst of all of the other podcasts. As we kind of brought up in the initial episode 0, we haven't really solidly pinned that down necessarily yet. But I think that we exist probably in the intersectionality between something like a combination of the Amp Hour and the Unnamed Reverse Engineering podcast and Darknet Diaries and any others to add to that.
I don't think I have any, honestly.
So yeah, I listen to regularly and love all of those. With most of the podcasts that I listen to in the STEM space, though, there usually is something that's kind of left to be desired when it comes down to like deep diving on the technical piece or getting kind of into the really nitty gritty nuts and bolts. And I think so. A strong motivation for this show was to be able to relay certain things as we learn them out to everybody else, because it's invaluable to be able to get a look at somebody else's like lab notebook, if you will. Unfortunately, it seems that most of us who are in this kind of space are terrible at taking notes.
And confirm.
And in addition to taking, if we do take notes on something, it's hard to capture experience.
Yeah,
But
so it's definitely the same for me. It's like when I'm taking notes, I'm always trying to like recreate the experience that I had when I was there, and when I go back and read it, it's just never quite the same for me.
yeah,
It never
exactly.
works out like that.
It's hard. It's hard to relay onto somebody else looking and watching these bits twiddle back and forth on the logic analyzer. I got the intuition from the rate at which it was going that there was going to be some other sort of curiosity mechanism that was involved inside of the MCU that I needed to investigate a little bit further. So, how do you put all of that simply into a write up?
I don't, I think.
You mostly don't.
I really yeah. That's always been difficult for me to capture, especially in writing. Hell, that's difficult for me to capture in words sometimes when I'm telling somebody something. It's like, yeah, because especially depending on who the audience for your write up is, you don't want to just toss out there that like, yeah, I found this thing is just intuition, so I investigated and it turned out to be what it was.
Yeah, I'm
Maybe
sure that
that's, I don't know. It doesn't look as bad as I think it does, but I'm always hesitant to do it.
my intuition is if you're doing it for a profession, then people aren't going to appreciate, well, I followed my intuition and this is kind of where it came out, especially in like engineering. But let's be real though, that's probably a lot more present in a lot of different people's projects than anybody likes to give it credit for. Nonetheless, so this show exists, I think, to try to help out in giving some higher fidelity into an insight to some of those types of projects that you'd come across. And it's always so much nicer when you kind of have a trusted insider or trusted, I guess, mentor to help guide you through that. So we hope to relate to you what it is that we've learned in the same way that others have done that for us. Not only that, but and not to get too philosophical here, but there's an old school commercial in the 90s that I think IBM had put it out there or something. So congratulations to them because the marketing stuck. But there's a tagline in there where somebody had said, capturing data is the first step towards knowledge, but sharing it is the first step towards community. And so the community of people out there doing STEM related stuff is one that I loved to have gotten dialed into, and only continues to help me just know in my personal life as well as my professional life. What are your thoughts on that, Dell?
I am definitely sort of getting bigger on the whole sharing thing as I get older. I have been on a lot of projects throughout the years, just in my time doing all this stuff where, I was just like, oh, yeah, like what is this thing? And then I'm just doing research and doing some more research, and then I find out that like 85% of the work that I've done has already been done by somebody else. And they just didn't say anything about it. They didn't share, it's like in a binder or something somewhere under a desk or under somebody's chair holding something up or whatever it happens to be. So I think for me, especially that part is really big. Like just figuring out how to get out there, get the information out, and like share as much of it as possible. And I guess whatever medium people like to consume it in. Obviously, we're doing a podcast now, but if we're taking notes or whatever at some point, that might be good too. Because I just get really frustrated when I'm redoing somebody else's work just because they didn't feel like writing it down or recording it or whatever it happens to be.
Right. Feel you on that. For this too, it could potentially morph into more in terms of us putting together something for a con or us putting out more content somewhere like on GitHub or at least if nowhere else, the show notes of our page, which was another criticism I think that we had received, or not necessarily criticism but recommendation. So the name of the show is the Reverse Engineering Plus Plus podcast, and the website is repp.show, SHOW. So on there, you'll find all of the different show notes that I allude to or have alluded to in the other episodes. I try to put a decent amount of effort into writing those up. And eventually, as we go through some more tutorials and walkthroughs type situations, that will be robusted up there along with the GitHub as well. So I think that about wraps it up for motivation for the show and things like that. And again, this one here is going to be getting into kind of the first steps. You have a board sitting in front of you. What do? One thing that I like to do is start to first, take pictures as close as I can to the different chips and start going out to a couple of the different sites that I know out there where there are decent chip manuals and things like that to pull down those. If you don't have the data sheet, then doing hardware RE is going to be a bad time.
That
And
is no joke. Also, if the only response when you're looking for a data sheet is alldatasheets.com, you are going to have a really bad time.
yeah, all data sheets avoid at all costs. What are some that you tend to like to use?
The best, obviously, is when I can get a manufacturer website, like NXP or TI or whatever. Post I'm Total Wind Bond, whoever it is. Um, that's the best, obviously, but I don't have anywhere specific I go after that. Just
There are a
whatever Google
few,
brings me that aren't those awful ones.
there are a couple at least, or a few, but I do know that outside of those, if I can't find them there, then it's usually Google Foo that I'm trying to use the name and then the typical Google hack for like the file type PDF. Occasionally you get
Yep, I
lucky.
was just gonna say that type PDF. Yeah. Open directory sometimes too. I feel like I've had good luck with doing the index of and title or whatever, to kind of steer it towards open directories.
Yeah, Google Dorking can help. Looking at a lot of different sites frequented by other people who would be doing something similar. Hackaday comment section or searching in Hackaday. So that's another Google Dork, like chip name and then site colon, Hackaday. Search engines, besides Google as well, can help depending on how exotic the part is. There's definitely some parts you'll run into that seemingly only have origins in Shenzhen or somewhere like that. So getting on Baidu, Baidu, or Yandex, or something like that might be able to find out. Then you get the data sheet. What's next?
Well, next for me, and I think for most people, is I want to start pulling any kind of memory I can.
Right.
I want images of every chip on the board if I can, binary images of every chip on the board that I can. Also, sometimes just to read the damn chip, you know what I mean? Like, I feel like chips are such a pain to read sometimes that I have literally taken pictures with my camera to try to get an idea of what the chip actually even is.
Yeah, and with that, you will oftentimes get some sort of success by like holding it at an angle if the writing on there is kind of smudged off or old, or purposely try to like they've sanded it down just a little bit. Dropping a little bit of alcohol on top can help.
Oh, no, I was gonna say I usually like drop a little bit of alcohol and then like wipe most of it, but not all of it off, right? And some of it seems to hang around in just the right spot to make the letters extra visible.
Maybe you don't have the right kit to be able to pull that type of memory down, but you will be able to find some sort of JTAG or something similar to be able to talk to the MCU, which is responsible for writing the thing. And if you have JTAG on it, you can often pull, the memory from the device itself if there's onboard for the MCU, or you might be able to pull some of the downstream chip info, or at least once it's loaded, once that memory that is in the chip is loaded and running inside of the MCU, you might even be better off because you'll have the full memory map of how things are laid out. You might during that process miss something, like you might miss the boot process, or you might not have access to, one of the other cores, secure cores or something like that on the MCU.
Well, I was just thinking like something you kind of just I've never had to really deal with like encrypted flash or anything like that before. And it makes me wonder if that'd be a better way to kind of attack that, right? Depending on where the decryption happens, right? Like if it pulls it off the chip and decrypts it and stores it in RAM there on board and you can dump it via JTAG, it seems like it's going to be a way better um, method of trying to decrypt that than whatever you were going to try before.
Yeah, probably important to say too that right now at the moment, I'm assuming that there's no kind of anti-tamper. There's no epoxy that they've dripped on top to be able to make it impossible to even see what the chip is to try to look for a data sheet if you could find one.
Yeah, that stuff is possible.
Right out of the gate for modern FPGAs, the storage for those inside of the tooling when you're creating and uploading like a new file is automatically like AES 256 out of the gate. And I don't envision myself
I
cracking
have
that
heard
anytime
that,
soon.
but I've never looked.
Yeah.
Yeah, it's definitely a kind of a different tool set you're going to want to grab for doing that. And I don't know anybody that's even given that a shot, honestly.
So uh, back to the central topic, which is, you've taken a look at the board, you've probably identified some flash memory, you find the data sheet for it, and then what are the typical types of memory that you are likely to come across?
Well, if we're talking flash in this day and age, unless you're working on like a car from the 80s, you're probably going to run into either serial flash or some parallel flash. Uh, Parallel flash these days is definitely going to be a huge pain. It's going to be like ball grid array type stuff, and then
Right.
it's going to be a bit of a challenge probably to get off the board and get onto a pinout or something like that. So if that's the case and you can JTAG the chip and dump it that way, then I think that's probably going to be your best bet.
Depending on what it is it NOR flash, is it NAND flash? But you added another dimension there when you talked about the form as well. You know, is it is it serial or is it parallel? And in addition to that, what's the pitch? How easy would this thing to be pull off the board? Do you have some sort of like hot plate
Or
or reflow or hot air to be able to pull it off? And can you get it back on after you've got it off?
yeah, especially if it's a ball grid array, are you going to be able to reball it? I don't know if you've seen basically stack them these days, right? So you'll have like your an
Yeah.
ARM core, like a system on a chip, quad core, whatever. You'll have your RAM stacked on top of that, and then your flash stacked on top of that, or whatever order it happens to be. And it's like, hey, you separate all that stuff, and like one of those chips in the middle, you need to reball both sides of that thing, maybe. Like
Yeah, I don't have
it can get
any
very
idea how to
complicated if
attack
you go
that.
on that route.
I've never seen a video of it. I've never had
Neither
to
do I.
experience it myself. I don't know what I would do if I had to. But
Do you need to put it back together? I mean, somewhere deep in the markets of Shenzhen, there's a dude doing this with like, an old Weller soldering iron and a magnifying glass,
it's not even a sharp tip. It's just dull. Somehow is able to do, 100
and
plus
using it
pin.
since the 70s.
There's no doubt in my mind, but I do not have those skills. So okay, so you have your flash, right? Then what tools are you using to try to pull the memory off that flash?
I have something we've talked about before. It is a TL866CS. I don't have the TL2. My particular one is actually hacked to a TL866 Alpha. I just found a forum online one time, and they were just like, yeah, like it turns out if you just tell it that it's a different thing, then it'll just upload different firmware basically, and unlock some of the other features. But that's pretty much what I use for all of my flash pulls these days. I also have in the past used kind of the crappier method, the jerry rig method of bit banging an FTDI chip.
Right.
Five.
I think yeah, if it's something like Spy Flash, then there are a couple of things that I have to approach that. Some are FTDI, like the chip manufacturer based. Those cables consistently work well. The non-generic ones consistently work well. For example, like the uh, C232HM DDHSL0, that guy has worked out pretty well. We've talked about in the past some of the other things, like I talked about the Shikra and
So
which
there are some projects out there too. If you've got a basic flash chip, especially for Spy Flash, where you can like upload a sketch to an Arduino, and
mhm,
then like they'll have a Python script to read it, but they are slow.
that's the main thing, right? The main thing that you're paying for when you're getting a device which pulls it faster, I guess, is what you're paying for, and what that really comes down to, I guess, is what is the rate of the thing you're pulling with, like what is the clock rate?
Yeah. Well, I think in the case of the Arduino, um, the microcontroller could get it off the flash faster, but I think by default, really, you're only getting up to like a 115 200
All right,
baud rate across the serial port.
yeah.
So you're going to be bottlenecked there pretty much every time.
I would also say that you can find the TL8662 and others out there, on the typical Amazon like link places and stuff like that, but you're going to run into like a lot of duplicates and clones and different things like that. So do your diligence in making sure that the one that you have isn't, a complete and other utter piece of trash. Uh,
I do not know if mine is a clone or not. It says Mini Pro on the case, but there's a sticker on the back that's just got some random letters and then programmer after it. So I'm not sure if mine's a clone or not.
yeah, it's harder and harder to tell. But I mean, even if it is, if it works
Right.
reasonable, that's cool. But a big word of caution for going out to probably what their recommended developer link is to pull down the software that they would use, what that you'd use to flash, the actual device. There is an open source one that you mentioned,
Absolutely.
right?
Yeah. So it's by a guy named Radio Man V on GitHub. He's got
Okay.
a TL866 GitHub repo, and it offers open source firmware and utilities. I've used the utility, but never the firmware personally. I do like it. Kind of, it's command line or was command line when I used it. I'm not sure if it's been updated. I haven't used it in about a year and a half.
Okay.
I don't know um, all the ins and outs of it, but I did like it, and I felt less sketchy about the software.
Right.
Right, the software felt less like it was selling my secrets to China.
A version that I found through, I believe, Hackaday in the comment section that somebody had talked about that I ran through Virus Total and ClamAV, and so with with this particular one too, you can do a lot more than just serial and parallel flash, right? There are other types of memory that you can pull with it or program with it as well, right?
Yes. So, especially older type chips like the 25 series, I forget the letter, but like the old 512 kilobit ROMs, EEPROMs, EEPROMs. So, both erasable with ultraviolet light and electronically erasable. It'll do all of that stuff, and you can also. I didn't. I believe you may have. You can buy the boards on top to add the compatibility for the different package types. Like the one that I have. I guess it's important to note it just comes with a 40-pin DIP ZIF socket, and so you just drop your chip in there and latch it down. It's got a little picture of what way to put it. But yeah, so you can dump pretty much everything. Like if you get the adapters, you can go to like an old 90s computer and like rip the BIOS chip out and read that if you're so inclined. So it'll do pretty much everything. It even has a ICSP header on it for in-circuit serial stuff.
I did buy the one that had all of the additional programmer sockets. The one that I purchased had something like 27 different adapter sockets, and that gets into what we had mentioned before, the kind of physical layout of the device you're trying to program or pull memory from.
Also, I can say that this thing, as far as electronically erasable, like those old parallel ROM, uh, man, I had really good luck. I was helping my dad with a project, and it was pretty much no problem at all to just write stuff and then move on. You can make I guess if you're really so inclined, you could probably make you some bootleg Super Nintendo games. when you dig down into it deep enough, you kind of find that Super Nintendo only had like a handful of boards. It was like 12 or 20. It was like 20 or less. So, like, kind of what happened for some of them is they would just put a ZIF socket in it, and then you could get some of those different boards. Some of them were really simple, some of them are more complex, like Super Mario RPG and Star Fox. Obviously, they got some of the extra chips on board that get more expensive and more difficult to find now
Mm.
that they aren't in production, stuff like that. And then they just have that ZIF socket, so you just burn whatever game you wanted to the chip, and it would do all the compatibility stuff to take it from like a standard mass ROM to um, reprogrammable memory chip, and then you just drop that in there and lock it down and throw it in your Super Nintendo and play you a bootleg game.
That is excellent. I'll have to see if I can't pull that information down from you if it exists out there anywhere, and we'll include that in the show notes too. I did end up finding, popping the stack back a little bit, some of the additional sockets and things like that that it supports, and man, it is a lot. There, the one in question, the for the TL866, has 27 of them, 27 different IC um, adapter styles. There are a lot. I think that it could be beneficial to at some point like enumerate a full list of those and show kind of examples and things like that too. A lot of them, though, to be frank, I don't run into very much. I've run into some of the little like SOIC 8, and I have run into some of the higher pin count ones on occasion, but I
Hmm.
haven't run into any that are kind of what you'd consider a little bit more in the more exotic range, or I haven't had to use any of the adapters that you would actually have to solder to. Nor do I think I would want to. I would probably just try to find a another one of the adapter sockets for that particular one that I could like just latch to and call it a day. But the main thing you do, right? You take the chip under in question, you try to desolder it or work it off with a hot air gun or bake it off or whatever. You extract it, and that same kit comes with like a little chip extractor too. You take it and put it inside of the casement for the socket, and then you take that socket and put it down into the big green ZIF on the programmer, and then cinch it down. The software itself has some pretty nice capabilities built in to allow you usually look in that software first to be able to select what type of chip it is that you're going to be putting in there, and then it will tell you the
Yep.
orientation that you put that in with, so you can kind of have some level of confidence that you're not going to break the device and you're not going to hurt your programmer. And then after you
I
have
think typically too. Sorry to interrupt, but I was gonna say I think typically as well, like it does a check beforehand. I want to say I remember like it kind of doing a check and then being like, hey, something didn't come back right, like the pins that were supposed to be high weren't high or whatever. So it like does a almost a detect ahead of time to know that something might be wrong before you actually start trying to read the device.
Okay, yeah. So for the next one, I think for the next episode, perhaps we'll throw a video up, maybe in the show notes as well, of going over a couple. I think I have a couple of different flash hanging out close by that I would be able to kind of show examples for. Would love, the ability to, if anybody had anything to send in, or as I go out, electronic shop, and I'll try to add more to kind of the repository of ones in my own, inventory, and maybe add to those video series or something over time, add to the common body of knowledge over time. That would be pretty cool. I'd love to too if anybody wants
Definitely.
to shoot out any info to one of us about some exotic one that you saw. I am Aaron, Aaron, at repp.show, and Dell is Dell at repp.show. Feel free to shoot a message to either one of us. I'd love to hear and see whatever it is that you have in your inventory.
One thing I do think maybe we should mention is there are some specifically there are a few devices you kind of have to build them yourself, but there's some stuff out there only for dumping. You won't be able to write or anything like that. But the one that comes to mind is the Tech Extractor is a big board that you can put different boards and stuff on top of and extract ridiculous number of chips with, but no write capability as far as I know. It's a GitHub project out there.
Okay, we'll check that out. Once you have your device, let's say you have NAND flash and you're wanting to pull the memory from that so that you can take that to an analysis tool to understand how this electronic device in front of you works. Either you're just trying to understand how it works and maybe modify it to do something that it wasn't intended to do originally, or just something you conceived of, or you're trying to look at it from a bug hunter's perspective to try to find vulnerabilities in it. Maybe you're after a bug bounty, or just generally trying to get a couple CVEs or something under your belt. So let's say it's NAND flash. What are kind of the differences that you see in NAND flash versus NOR flash in terms of how you pull it down, or how the memory is accessed, or how the memory is laid out?
Well, NAND flash, you can't really get a true like random read or write on, right? You're only reading or writing basically in pages, whatever the page size of that chip, happens to be. But NOR flash, is the opposite there. You can do random read and writes.
I was going to say, I think I've been
But
fortunate enough
sorry.
to only ever, like, anytime I've run into something that has had NOR flash, I've been able to JTAG it and be able to pull a memory that I've needed via that method over JTAG versus having to off chip the flash. But back to what you were saying.
Yeah, having to pull the flash can be kind of dangerous, especially if you're not like real confident with your soldering skills. So I was going to say the page access kind of leaves things open for the possibility of stuff being left behind after a write if there wasn't an erase. So you write to a particular space there, and you only use like say the first 200 bytes of a page, and then if it's a 16K page or whatever have you, whatever was written to that page before, if it wasn't erased, it's still just hanging around.
Right. So some opportunities there to be able to glean maybe some insight to something that was there before. There's also some pitfalls that you can run into, right, in pulling that. If you're pulling NAND flash and you don't know, the option that will pop up sometimes is to see if you want to pull like the additional slack space. And what that is an additional maybe 64K or something like that that's tacked on to the end of some of those page lengths. And the reason for it is for kind of like over time, certain cells go bad. There's a mechanism in place that allows it to mark bad blocks, and you still want to be able to have in aggregate roughly the same number of memory in terms of space that you always have. And in order to kind of meet that need, or hold their end of the bargain for making sure that that flash is still the same size, they have the additional space that isn't normally accessible, if you're using the device while you're running the device it's on, but you can 100% obviously access if you're using a programmer to pull down or send memory to the flash itself. Flash memory, for the most part, comes in different forms. We had mentioned SPI, we'd mentioned NOR, we'd mentioned NAND. We hadn't mentioned yet eMMC. So all of
Oh,
those
I
do,
forgot all about that.
right. And so eMMC is used more in your kind of like actual like cards that you'd use, like what we would call flash, like flash cards. And each of those have like the outside casement. The common ones are TSOP and BGA. Spy Flash is usually the easiest, in my opinion, to go after.
I was gonna say for at least depending on the situation, if it's like a SD card or something like that with eMMC inside, you might still be able to get after it with something that can do spy. You might have to find some like custom stuff, but it's not uncommon for microcontrollers and stuff like that to be able to read SD cards with their spy ports.
Yeah, I've seen some different people attack those by the microcontroller for the actual SD card itself. There's not a tremendous amount of work I think that is done in that space, but the little that I have seen goes deep. You can get really off into some really small, esoteric, weird chips and exotic stuff really quick. I think though that with the eMMC, thankfully for the most part, I don't think you typically have to get that to that deep of a level. I've never had to do that myself, so I can't really necessarily comment to say talk about the relative ease or difficulty, other than kind of what I've seen through some other presentations and stuff like that from others. But yeah, so you've got Spy Flash, right? You got NOR Flash. NOR can be up to like 46 pins, and that pin map can be all over the place depending on the chip vendor. NAND has typically like 8 or 16 pins that both address input and data output, and they're multiplexed across the protocol. And the pin maps for both the BGA and TSOP are pretty standard, unlike NOR, which can wildly differ depending on chip vendor. eMMC is basically NAND, and then the controller is kind of there in the way. So the controller can result in an interface that can be vendor specific, but there's also kind of a standard. You know, there's the de facto and de jure standards for different, I don't know, just everything in life really. Like de facto, you know, being the thing that everybody kind of agrees upon, although there's not an official standard, and de jure is just like the of the day type of standards, like what's common or popular right now at this moment. But the
Yeah,
BGA map,
and that is kind of convenient about it.
I think what's convenient about, or I'm thankful that regardless if it's a de facto or de jure standard, there are a lot of people out there who end up putting out kind of like, hey, I face this. Here's kind of what the popular thing is now at the moment, and that's again nice
Hmm.
to be able to rely on other people to take a page from their playbook. Typically, but not always. You know, with Spy, I have been successful. There's a little like SOIC 8 clip that I have, which has male header pins on top, which I'll hook the C232 HMF TDI cable to be able to pull. Because with Spy, it's a pretty simple interface. There's usually 8 pins. Your ground, your chip select, your clock, your hold, or not chip select, chip enable. And then you'll typically have like your SO and your SI. You can check out flashrom.org to see if your chip is supported by what something like the 866. But there are other people out there too who, as Wade mentioned earlier, had written sketches that allow you to pull those off as well with an Arduino. It's going to be slow. I think the same is true
Yeah.
for Raspberry Pi. It's possible over the GPIO of a Raspberry Pi to be able to do that too, with different configurations that people have out there. Try to find some of those, and then using like FlashROM, the command line utility, setting the speed. You set your device, and then you pull it that way. So NOR can be much more complicated if you're trying to do like a parallel flash dumper with an Arduino or Raspberry Pi. Have some pretty good detailed information out there that exists on the internet on how to do that. But typically, you'll want to, with the Arduino sketch, people will typically have some shift registers that they have in addition to the sketch that you've got loaded into the Arduino. You off board the chip. Sometimes you can get away, I think, with doing it inside of a breadboard without too many issues. But like most things that are on a breadboard, you don't really want to rely on them wholeheartedly. Especially is true with like radio related stuff. It's just the traces and the little small wire hookup wires and things that you're using are too thin to support robust data throughput, and they're easily susceptible to like noise that's around, whether that be clock noise from the device under test that you're messing around with, or some power cable because you've got this thing hanging off of your computer down by the side, and you've got all sorts of other electronics which are just pumping out energy and all over the place around them.
Doing
Um,
it literally right next to a switch mode power supply.
the moral of the story there is while you can get away with it, it's probably better to be able to, if you're attacking NOR, not use it with some shift registers in Arduino, but instead like put it onto something a little bit more robust. I hesitate to call the 866 more robust, but it's probably better than some of the hookup wire stuff from a Arduino and some sketchy breadboards.
So that's definitely true, but I will say that there are like a very few cases out there where they'll actually have an interface just kind of for you. I want to say I was watching like EEV blog or something like that, and he was reprogramming the BIOS on some motherboard that he had found in like the trash or something. And it just had a header for him to plug into to reprogram the flash chip that was on there, which seemed super convenient to me.
It's a nice coincidence.
It is a nice coincidence, but also equipment manufacturers out there, if you could just start doing more of that so that I didn't have to go so much effort to steal your stuff, that'd be great.
Thankfully, like I said, I have not had to experience pulling stuff from NOR very often. Maybe a handful of times, to be truthful with you, that I wasn't able to like JTAG something. But there are a couple different ways you can do it. Off chipping it is also obviously difficult with the increased number of pins. Thankfully, I think most of what you experience on most stuff these days is NAND. And
Yep.
the cool thing about NAND, not only from an operations standpoint where you're going to be able to use NAND typically for longer, I think that in general it has more write cycles than NOR. But it does that with fewer number of pins, so it's going to be less things that you're going to have to contend with if you're hooking it up to something like the Arduino based NAND dump, the dump NAND memory. And with that, with having so unless it's something like a BGA or something like that, you're typically going to be able to be moving with it pretty quick. Separately from NAND with eMMC or eMCP, since there are a lot of devices maybe you'd be encountering that use like USB and would have one of these associated with it or attached to it or like some sort of like SD. So eMMC is like NAND in that the like memory controller that is controlling all the bad blocks and everything like that is integrated into the chip itself. eMCP,
So I think that's even, but I think that's even to the point where like there are devices that basically have like SDIO interfaces for different hardware that'll interface kind of directly with those eMMC chips.
right,
In that way, you don't have to worry about like any of the management or like it's just all set up for like doing everything on its own and interacting with that interface.
right.
I haven't tried to pull anything straight off a chip with those, but it always kind of felt like it'd be really a huge pain in my ass.
Undoubtedly would be. And in addition to, I haven't seen it, but there's also eMCP, which is similar to eMMC, but it also has RAM. I think the thing that is nicest to work with is typically hot air. There are some pretty cool kits that you can have out there that have a little heat deflector, which prevent heat from the hot tip going over to other components and leaking over, which is especially nice if you have a board which has a lot of those really, really small surface mount components. But also, it kind of tends to go faster, right? Because all of the heat is deflected and kind of piped toward the device that you want to pull. They'll also have like a little suction cup type thing that can go down onto the top of the chip so that while you're
Hmm.
heating it, like the first moment that those contacts can like let loose, it'll pull the chip up so you don't have to worry about damaging the device. So that's nice.
That is definitely some fancy pants hardware that I usually do not have on hand. Typically, if I'm doing something like that, I'm just straight hot air onto the chip, or if it's like a SOIC 8 or something like that, I'm just gonna float it and hope for the best. Snatch it out of there with a pair of tweezers before something goes wrong.
The old trusty Leatherman wins again for holding on to something
I
while I'm trying
don't
to
use a
float
Leatherman. I have tweezers.
it.
Even if it's not like actually holding on to it with the pliers, right? Like I definitely have more than a few things around my table that I regularly use to just hold stuff down while I'm trying to work on it instead of getting a proper like third hand tool.
Yeah. You mean a flathead screwdriver just propped underneath and slowly applying pressure gradually more as it releases isn't good enough? I've been lied to all these years.
Yeah. Thought I was making waves here. I was gonna start selling these.
The repp.show chip extractor. Customized for all of your chip extraction needs.
It's got to be the worst screwdriver too, you know?
Oh yeah, the kind that have those really
Go.
it's not even like the nice like heat treated plastic handle. It just disintegrates at the first sign of any kind of mechanical vibration or anything.
Absolutely. It's that like semi-clear, like ultra rigid plastic. It smells a little bit like cancer.
I think that yeah, I think that that maybe is a good place to stop with regards to talking about like the flash extraction for now because a lot of this doesn't make as much sense as like maybe a video would, but we'll try to have this be the first part in the series to introduce the topics, and in the next one we'll robust out the show notes to have maybe some additional pictures and maybe some scripts and stuff like that to show to run it. All right. I think that that's a good, introduction for some of the topic of pulling memory off. Kind of one of the first things that you're going to be getting into if you're looking to get into hardware reverse engineering. Anything out there for the listeners, Dell?
Just honestly, you gotta kind of get out there and do it. It's not gonna be a thing where you're gonna read about it and be perfect at it. Just go to your local Goodwill or electronics recycling, whatever, anywhere where they'll let you like yank electronics or buy them for cheap out of like a trash can or whatever. and without getting arrested, preferably, you just start finding flash chips or anything, any sort of memory you can find on there, and start trying to pull that stuff. And then compare it against any firmware you can download or whatever to see how good it is. But you got to kind of get out there and give it a shot. It's pretty much my recommendation for anything.
I think that's a great recommendation. I think that at things like information security conferences and things where they have a hardware hacking village, I have typically experienced a big bin of stuff that people bring. So that can be all over the place in a lot of ways. And also it's kind of first come first serve. That could be another recommendation for places to check out. In general, if somebody's getting rid of an older, I don't know, let's say stereo system or something like that, if you're getting into the hardware business and playing around, there could be at least some of those big power caps, capacitors, and those can be nice to
Hmm.
pull off. So in addition to pulling off the pieces that you'd want to play around with like flash, there can be all a wealth of all sorts of other things, especially I feel on power supplies. Power supply resistors, power supply capacitors are nice to be able to pull off and kind of throw into your bin. Also,
I would say also, so if you got like a computer recycling area near you for both flash chips, especially if you can find some newer motherboards that people are getting rid of because of whatever reason, the voltage regulators are going to have some good, um, some good FETs in there, and then you can also pull the flash off there and read the BIOS off of that. And if you got the part number, you got something to compare it to. Usually they'll have those binaries on a website somewhere.
another thing that you can definitely do as well is scour eBay for some of the older development kits. Whether
Yes.
or not you're looking for an FPGA that also has some flash memory that's associated with it, or any other type of MCU development kit, it's probably going to have an associated flash and some input output type devices. So you can get proficient at both programming that device as well as seeing how you can manipulate and use that memory. So something that you could potentially do is buy one of those older development kits, do a really simple program that you could probably find off of a tutorial from the like site for the manufacturer, and then try to pull the flash off of that. And the cool thing about that is that you then kind of have a real solid understanding of what's going into it. So it can't be, if you're starting out, if you're a little bit more experienced in, computer science, computer hardware in general, and you want to start doing more RE, more bug bounty, then by all means go out there and grab an IoT device from your local Goodwill and hack away. But if you're at the beginning of it, it can be helpful to kind of ride those training wheels of getting a development kit and trying it out that way. Also, as a word of caution, you may run into some things sometimes that are surprisingly hard to get after. Case in point, things like greeting cards are surprisingly hard to try to get at. And the reason that they are is because whether it be an electronic toy or whether it be something that's kind of really high volume like that, they don't want the manufacturers and they don't want other people to copy them. So oftentimes they'll at least put something down like epoxy on the flash memory as well as the microcontroller or whatever is in use. Despite me saying that though, don't be discouraged. I mean, Dell had just said if there's something out there, there ain't nothing to it but to do it. You're going to just have to start getting your hands dirty and getting after these, and you may be successful or you may have a pile of burnt chips at your feet. Either way, you're going to be learning something and having fun along the way.
Yeah, I think that's the important part about, or to me, that's kind of one of the driving factors for finding cheap stuff that you just really don't give a shit about for practicing on or learning on and stuff like that. It's just like, man, you're gonna fuck them up. Like, if it's got some epoxy on there, whatever. Just douse that guy in some, mineral spirits or fucking isopropyl alcohol or whatever. Heat it up real hot and see if you can scrape that shit off. The worst that happens is you break a thing that you weren't super concerned about to start with.
Yep. But okay, so I think that's it for this episode. Probably we'll be following up with a part two in the next episode. Thanks everybody for listening in. Again, this is the Reverse Engineering Plus Plus podcast. Come out and visit us at repp.show. That's repp.show. Feel free to shoot, recommendations or ideas or, hey, you said that thing wrong to either myself at Dell at Aaron at repp.show or Dell at repp.show. All right. Thanks everybody for listening. Bye.
repp.show. Nerd Talk IO.